All right, hey everybody. So here we are going to talk about how to calculate force and acceleration from an object that is at rest, okay? So if you look up to one of my other videos, we calculated an object that was moving when we started to calculate acceleration. It had an initial velocity, but this object, this parachutist, much like the project we're doing in class, is going to start with a velocity of 0, relative to the ground. So the parachutist, I actually had to look up how to spell that word. A parachutist jumps from an airplane. He has a mass of 70 kilograms. He falls for 175 meters and lands in 23 seconds. What was his force when he hit the ground? All right, so Mr. Bun's art skills here. I got a little airplane. Bun Airlines right there. And it's traveling through the air. Now, he jumps out, okay? And here's our parachutist. And this is his initial velocity, okay? When he first starts, he has a velocity of 0 meters per second. Oh my gosh, what's going on there? He has a velocity of 0 meters per second, okay? He's starting from rest. Now, he probably has a little bit of forward, velocity, a little bit of downward velocity, but we're gonna assume it's at 0 meters per second. Okay, and he falls, and he is going to hit, he's going to hit the ground, and we want to know what is going to be his velocity, his final velocity. What is going to be his velocity there after he has traveled for 175 meters and after he has fallen for 23 seconds. Okay, so there's a lot of stuff we got to figure out just to answer the question. The question says, what was his force? So we need to measure force. What was his force when he hit the ground? Okay, so again, let's write out what we have, what we want to know, and let's get to cooking here. All right. So first of all, we want to know force, okay? That's the big thing here. We want to know force. And we know that force equals mass times acceleration. Okay, well, what do we have? We obviously don't have force, but we have mass. That's good. Mass. His mass is 70 kilograms. That was right here in the problem. But the problem is, we don't know acceleration. Okay, we've got to figure out acceleration before we can find force. So what is acceleration? We know that acceleration equals change in velocity, change in speed over time. So his final velocity, right there where he hit the ground, hopefully he hit softly, minus the initial velocity, what he started with, divided by the time. Okay, so we're trying to figure out acceleration. The final velocity, you guessed it, we don't know that. Okay, we gotta calculate it. Okay, do we know initial velocity? Well, we sure do, because he started from a rest. He started from jumping out of that airplane and he started to increase his velocity. So he started with 0 meters per second, and then we want to know time. And time was given to us right here, 23 seconds. 23 seconds. Okay, so now we've got to figure out that final velocity. Okay, we've got to figure out the final velocity. What happened, when he landed. And velocity, whether it's final or initial or whatever, equals the distance traveled divided by the time that it took. Do we know distance? Yes, we do, because it's given right there, 175 meters. 175 meters, and we also know time, because that time was the same right there at 23 seconds. Okay, so through the magic of the iPad, magic of preparing ahead of time, I've gone ahead and done my calculations. Okay, so it's going to be a little quicker, but again, make sure you always bring your calculators to class. So velocity is distance divided by time. Velocity equals the distance, 175 meters, divided by 23 seconds, and I get my velocity at 7.6086. We're going to round to hundredths. Okay, so we look at the thousandths place. It is 5 or above, so we round up. My velocity equals 7.61 meters per second. Okay, that's very important because we're going to plug it in right over here when we start to calculate our acceleration. So acceleration equals the final velocity, what we ended with, we just calculated that. 7.61 minus the initial velocity. Initial velocity here was 0. So that's easy peasy. Minus 0 divided by the time. Time was given in my question right here of 23 seconds. 23. So acceleration is 7.61 minus 0. What is that? Oh, 7.61. And then we divide that number by 23, and we get 2.5366. Round to hundredths, we get 2.54. Now this is going to go up into acceleration. You know, we had to find our final velocity and plug it in. Now we found acceleration and we plugged it in. So force, you know, force measured in newtons is mass times acceleration. Force equals the mass times acceleration. Mass, where did we get mass? It was in the problem. So 70 times acceleration, which we calculated down here, is 2.54. Okay, so 70 times 2.54, our force equals 177.8. Don't forget newtons, wham bam, we have calculated his force of 177.8 newtons. Now, this is exactly what we're doing to save Mark, okay? The save Mark problems, the save Mark assessment is requiring you to create some kind of device to keep Mark from smashing into the ground very hard. So how are you going to do that? How are you going to keep the force very, very low? Hopefully you enjoyed this video and you learned something. Have a great day.